All right. Earlier in our class, we learned about the derivative function in regards to the rate of change. So as the y increases, the x also increases, and you would have a positive slope for that derivative. The opposite is true when your slope is negative. Your y decreases as your x increases. So on this next slide are some examples of rates of change. For example, temperature varies continuously. The height of a tree increases as it grows. The price of stocks and shares vary with each day's trading. So we're going to model these quantities using functions of time. The derivative of a function tells us the rate at which the quantity is varying. So for example, h of t models the height above the ground of a person riding on a Ferris wheel, where the derivative is the person's instantaneous rate of ascent. It might have the units of meters per second. Another example, the c of t models the capacity of a person's lung, where the derivative would be the instantaneous rate of change in the lung capacity as the person breathes. It might have a unit of measure as liters per second. So here's an example. The volume of air in a hot air balloon after t minutes is given by this function. And we want to have the interval from 0 to 8 minutes. So part A says find the initial volume in the hot air balloon. So we're going to let t equal 0 in that function. So we'll substitute 0 in for time. And what we're left with is 2 meters cubed. Part B says find the volume when the time is 8 minutes. So we're going to let 8 be the time. So we'll substitute 8 in for t. And then we would substitute that into our calculator. And we get 914 meters cubed. Part C says find the derivative. So we're going to use our power rule. So I'm just going ahead and write our function again. All right, we're going to bring down that 3, subtract a power, bring down the 2, subtract a power, and then just drop that t. So our derivative function is 6t squared minus 6t plus 10. And then our unit of measure is meters per minute. And then part D says find the rate of increase when the volume is 4 minutes. So we're going to let t equal 4 minutes into our derivative function. So we'll substitute 4 in for t, and then simplify it. So we would get 82 meters cubed per minute. So that is the rate of increase at 4 minutes.